Hello, my name is Louis Fagon. I'm a French PhD candidate in history at EHESS in Paris, working on the history of nuclear industry along the Rhône River in France since the 1950s to the end of the 1990s. I will present to you my paper on radioactive effluent control on a single nuclear plant, Marcoule. When you think of radioactive containment, various pictures come to mind. Barrels, radiation shielding solid materials such as uranium or plutonium, invisible radiation in the air. But what happens to the liquid effluents? How do you contain a liquid and its radioactive hazard? These effluents are constantly produced by every nuclear facility. Water is constantly pumped from the river. A part of this water is used as a coolant and leads to non-radioactive effluents. But some water is used also to clean facilities, bodies, reactors, and becomes radioactive itself. This water is then discharged through a specific drainage system into the river. In 1976, 100,000 cubic meters of radioactive effluents are being discharged from Marcoule into the Rhône every year. Using local archives, especially the ones of the administration in charge of controlling the river, the water use, but also the one of the health administration or agriculture administration, this paper documents the evolution of radioactive waste containment on a macro scale from the 1950s to the early 1980s. I chose to focus on this particular site, Marcoule, for two reasons. First, the site is established in 1953. This is one of the oldest nuclear facilities in France, which allowed me to conduct a long-term study. Secondly, this is a nuclear complex. In 20 years, numerous reactors and laboratories are being built, both for military and civil use. You can find EDF, the electric utility company, on this site, but also CEA, mostly CEA, the French Atomic Commission. I will summarize my three main results. First of all, we can see a change from a containment by the river to a containment to protect the river. During the 1950s, the river itself is seen as a natural barrier. A sufficient dilution of effluents is supposed to annihilate radioactivity and to disperse it within the natural radioactivity of the water. Sediments are even supposed to avoid radioactivity going into drinking water, for example. This conception slowly changes during the 1960s and the beginning of the 1970s, with, for example, researches being conducted on vitrification, containment on site, and stricter treatment of effluents to avoid dispersion. Secondly, the technical solutions materialize this change. During the 1950s, engineers conduct experiments to find the perfect way to dilute radioactive effluents, for example, by designing specific pipes. But after the 1960s, these effluents are separated from each other. Depending on their nature and their radioactivity level, these effluents circulate through different drainage systems and different pipes. The most radioactive ones are stored on site, some of them for 10 years. Chemical treatments are developed to extract radioactivity from the water and to concentrate it into sand or into sediment or even into mud. Finally, on a larger scale, the spatial impact of radioactive effluents extends beyond the local area. First conceived as a local problem during the 1950s, for example, for local agriculture or downstream cities pumping the water, radioactive effluents are controlled mostly to reassure local opinion during this period. But due to various factors, this impacted area extends to the entire river at the beginning of the 1970s. Official reports, for example, mention the need to study everything more or less directly related to the water of the Rhône River. In conclusion, by focusing on water and liquid effluents, we can observe a three-dimension change of radioactive containment, conceptually, materially, and spatially. Thank you for your attention.